Welcome to two-dimensional arrays in Python. Understanding 2D lists in Python. A two-dimensional list in Python is essentially a list of lists. This allows you to store information in a table-like structure, which is particularly useful for representing matrices or grids. Each inner list acts as a row within the larger, outer list. This makes it easier to organize and manipulate complex data. In this code example, we create a two-dimensional list called matrix, containing 3 rows and 3 columns. The for loop iterates over each row within the matrix and prints it out. This shows how you can access and display the rows of a 2D list efficiently. The output displays each row of the matrix on a new line. Accessing elements in 2D lists. In Python, a two-dimensional list is simply a list of lists, making it possible to organize data in a grid or table-like structure. You can access each element using its row and column indices. Indexing always begins at 0. Here, matrix equals a 3x3 grid containing the numbers 1 through 9. The code selects the value at row 1, column 2, which is 6. It then retrieves the third row as a sublist. Next, the first item in the matrix is accessed using the 0 indices for both row and column. The center value of the grid is selected by specifying row 1, column 1. Finally, the last item in the matrix is accessed from the third row and third column. Modifying 2D list values. Indexes start from 0. You access the outer list first, followed by the inner list. This is important when working with multi-dimensional lists in Python. Here, we create a two-dimensional list called matrix, containing 3 lists of numbers. We then modify the value at row index 1 and column index 2. This updates the number 6 to 10 in the matrix. Printing matrix now shows the updated structure. The final output is a nested list: 1, 2, 3, 4, 5, 10, 7, 8, 9. Iterating through 2D arrays. Iterating through two-dimensional arrays allows you to access each element in a structured manner. In this example, we define contacts as a two-dimensional array, where each row contains a name and an email address. The loop unpacks each row into name and email, then prints them in a formatted manner. The output displays each contact's name and email, neatly aligned for readability. Using nested loops with 2D lists. Nested loops are essential for working with two-dimensional lists in Python. They allow you to iterate through each row and column effectively. In this code, we create a matrix, which is a list of lists, representing a grid of numbers. The outer loop goes through each row in the matrix. The inner loop then goes through each element within that row, printing each number on the same line. After completing each row, the print statement moves the output to the next line, so each row appears beneath the previous one. This produces a neatly formatted output, displaying the contents of the matrix in rows and columns as you would expect to see them. This shows how nested loops enable you to access and display every value in a two-dimensional list. Common errors with 2D lists. Common errors with two-dimensional lists often occur when indices are accessed or manipulated incorrectly. It's easy to confuse the dimensions when working with rows and columns. Here, we have a two-dimensional list named matrix, containing 2 rows. The code attempts to access an element in the third row, which does not exist. This action causes Python to raise an index error, indicating that the list index is out of range. This shows the importance of carefully checking index values when working with two-dimensional lists, to avoid accessing elements that do not exist. Appending items to lists. You can add new sublists or rows to a list of lists in Python, or append items to an existing sublist using the .append method. Here, we have a matrix represented as a list of lists. By calling append with a new list, we add a new row to the matrix. This is useful when you need to expand your matrix with additional data. Next, we append an item to an existing row. By selecting the first sublist and calling append, we add the number 13 to the end of that row. This technique allows you to modify individual rows without affecting the rest of the matrix. Deleting items or sub-items from 2D lists. In Python, a two-dimensional list is a list of lists, which allows you to organize data in a grid-like structure. You can remove elements from specific rows, or delete entire rows, using methods such as .remove or the DL statement. Here, we define a variable named matrix as a two-dimensional list containing 3 rows. We remove the number 2 from the first row using the .remove method. This operation leaves the first row with only the numbers 1 and 3. Next, we use the del statement to remove the number 6 from the second row by its index. As a result, the second row now contains only 4 and 5. Finally, we remove the entire last row using the del statement once again. The matrix is now reduced to 2 rows, the first containing 1 and 3, and the second containing 4 and 5. This demonstrates how you can efficiently modify two-dimensional lists in Python by removing specific elements or entire rows, enabling flexible management of grid-like data. Example: Rectangles calculator. The console displays rectangle 1. We see the prompt, enter length. Program waits for us to enter a value and press enter. Next, it prompts, enter width. Again, the program pauses for our input. After entering the width, the program moves on to the next rectangle. It now displays rectangle 2. We repeat the process, entering a length and then a width. The cycle continues for rectangle 3, with prompts for length and width. After all 3 rectangles, the program prints a blank line, then areas of the rectangles. For each rectangle, it displays the area in order. We see output like rectangle 1, 20.0, rectangle 2, 15.5, and so forth, depending on our inputs. All 3 areas appear in the console, one after the other. At the end, we have a clear summary of each rectangle's area.